Hi, my name is Oliver, a software engineer at Google, and I'm here to talk about some work we've been doing in the vulnerability management space for open source. So open source is widely used by pretty much everybody, which means that the security of open source is very important to the foundational security of the internet and software ecosystem as a whole. When a vulnerability is discovered in a software project's open source dependencies, the developers need to be promptly notified in order to remain secure and avoid getting exploited. Today, this is very difficult to do, as dependencies can span multiple package and language ecosystems. Handling dependencies can also be very complex because they are often part of large transitive trees of dependencies rather than being direct dependencies. There are also multiple vulnerability databases that they need to care about as well. So what ends up happening is lots of manual triage is typically required to stay on top of these, and new package versions which contain vulnerability fixes are easily missed. As an open source library user, there is no standard vulnerability format or database, or even tooling that can be easily used across different language ecosystems. Users have to handle each ecosystem and vulnerability database separately, with different parsers and version range handling for each. Some language ecosystems, such as NPM, have out-of-the-box support for vulnerable package detection through NPM audit, while others, such as Python, do not provide any out-of-the-box. There is just no common tooling or standard here. CVEs are commonly used today to describe vulnerabilities, but it's very difficult to use them directly to manage vulnerabilities in open source. The key issue is that a CVE often does not have any machine-readable fields that match reliably against the package name and a set of effective versions in that package manager. CPEs are commonly used in CVE entries to identify a software and version, but they don't map well to real package names. An example here is the CPE for a Ginger 2 vulnerability. The CPE refers to Ginger without 2 in the name, but the actual package name in the Python package repository is Ginger 2. Other libraries with numbers in the name do end up having the number included in the CPE. And in general, the names used in CPEs do not consistently match the package names and versions in real package managers. On the flip side, from a vulnerability database maintenance perspective, CVEs are also difficult to request and require lots of manual work to generate. As a result of these problems, there are many different vulnerability databases started up by different groups, such as GitHub security advisories, and there are also community-maintained vulnerability databases for language ecosystems such as Ruby or Rust, and then there are also non-free commercial solutions such as Snyk. So to try to unify vulnerability management in open source, we launched something called OSV, which is short for Open Source Vulnerabilities. It's a vulnerability database and automation infrastructure for open source packages. For each vulnerability, we track the precise version ranges that are affected and make it easy to match the package names. On the right, we have some examples of vulnerabilities we currently track. So this started with a completely automated dataset of a few thousand vulnerabilities from a continuous fuzzing service we also run called OSS Fuzz. And we've been working hard to expand our sources of data as well to include other package ecosystems. To consume this data, OSV provides a very simple ecosystem-agnostic API that allows users to query for package vulnerabilities by providing either a Git hash or a package name and version number. Git hashes are unique, so they're the only thing that need to be specified as shown in the first example. Otherwise, the package name and ecosystem name need to be provided along with a version string. This then returns any vulnerabilities that correspond to those input versions. We record and return vulnerabilities using a very simple and minimal JSON format. Here's an example of a fictional vulnerability in the Ginger 2 Python library. And the key feature of this schema is that we record very clearly the package name affected and the very precise version ranges using Git hashes and version strings that match exactly what's used in the package manager. We're also trying to standardize this format to be used for other vulnerability databases. And you can find the spec by going to tinyurl.com/vuln-json if you're interested in providing feedback. We've already engaged with many other existing vulnerability database maintainers, such as GitHub, for their feedback and incorporated them. Our ultimate goal with the schema is for it to be a simple interchange format that all vulnerability databases export. Services such as OSV can then aggregate all this information easily and then present a consistent view of all open source vulnerabilities to users. This will help reduce missed vulnerabilities and promote common tooling that works regardless of language and package ecosystems. The Go team is already planning to adopt the schema for their upcoming vulnerability database, and we've made progress with the Python and Rust communities as well to export their vulnerabilities in the same format. So making it easier for users of open source to consume vulnerabilities is just one part of the story. We need to have quality vulnerability databases with precise version data in the first place, which usually requires lots of manual triage work. To help with this, OSV also provides automation tools to help with determining impacted version ranges, as well as scraping existing vulnerability feeds. For vulnerabilities with machine reproducible steps, OSV will perform bisections automatically to determine both the commits which introduce and fix the bug. From there, we can look at repository tags to determine the list of versions that are affected. This is how every vulnerability from OSS fuzz is triaged, with no human involvement in the entire process. And here we have a real example of a vulnerability entry where an OSV Gitbot appended the list of affected versions given the input commit ranges. And finally, for vulnerabilities that aren't easily reproducible, we've been building tools to reduce the manual workload required to triage existing vulnerability feeds, such as CVEs, and extract as much version information as we can. And we also try to match these to package names and package versions. In cases where version data isn't readily available, we try to parse vulnerability descriptions to extract version numbers, make sure the valid version numbers in the package manager, and output them in our formats. Some manual triage work is still required, but we're building a workflow where this is minimized as much as possible. And we're planning to use this to bootstrap a community-owned database of Python vulnerabilities very soon. And that's about it. If you want to read more about some of this work, here are some links that you can explore. And now I'll hand it off to Anne, who has been working on developing a framework for handling vulnerability disclosures in open source.
Awesome. Thanks, Oliver. So Oliver was talking about how to find known vulnerabilities that affect your project, but what if your project is where the vulnerability originates? We're going to be talking about how you handle that when you get that email that says, hey, I have found a security issue in your open source project. The process we're going to be talking through is coordinated vulnerability disclosure, and we'll go over what that is. We're going to go over how to set it up if you're an open source project maintainer. And if you're a user, keep paying attention because you might stumble across an issue as you're using this project, and it's really important that you know what this process looks like and how to be involved in it. And a caveat that this is the condensed version. There is a lot to vulnerability disclosure, and if you're going to implement it for your project, there's a handful of decisions that you need to make. Fortunately, we put this all up on GitHub. So if you head over to github.com/google/oss-vulnerability-guide, you will see a huge reference guide with tons of material there. There's a runbook if you just want to know step by step, tell me what to do. And then there's templates, which we're going to go over in a little bit as well. So I keep saying coordinated vulnerability disclosure. Vulnerability disclosure actually has many models. There's not just one. There's multiple processes for verifying, communicating, triaging, documenting a vulnerability. Some of those you might hear are full disclosure, which prioritizes getting out information as quickly as possible and as widely as possible. And you might also hear private disclosure, which prioritizes keeping information on a need-to-know basis. And you might hear things like silent patching involved in private disclosure. Coordinated disclosure is a model that acknowledges that both the product or project owners have some wants and the reporter does as well. And those two groups are going to have to work together to figure out how they protect users, avoid compromise, but both end up getting a solution that works for both of them. So let's walk through the life of a vulnerability in CVD. Don't worry, you don't need to take the slide in. We're going to go one by one from the first step of intake all the way through to disclosure. So let's start exactly at that top. This chain kicks off when someone finds an issue and decides to notify the project team. So here is our researcher. It's actually my dog. He got a promotion for today, but here he is. They found something shouldn't behave this way. They want to know, how do I contact the right people in the project? So let's talk about that right people group. Who is that? Who is that? You probably want to set aside a small group within your open source project to be the people who will respond to email or however you're going to set up your intake, respond to those intake reports, and deal with coordination and triage. It doesn't have to necessarily be all security engineers. These aren't necessarily people who are going to fix the project. They're really on just the hook for taking in reports and triaging them. I should also mention some open source projects might only have 3 people total working on them, in which case you are the vulnerability management team. The other thing is that you want to put this information in an obvious and easy place. By obvious, I mean don't nest it under something like /governance /community. Your researcher is probably going to give up before they find that. And then you're going to have just, a loose vulnerability on Twitter that you really wish you would have had some early heads up about. By easy, I mean don't add any more friction to this process. The reporter has already done you a favor by deciding to notify you. That's fantastic news. So don't do things like adding new tools that you only use for this one purpose or multiple steps. Email is actually really quite fine. It fits all those boxes. If you are going to use one of these tools, having email as backup is a really good idea so you can make sure that people can get a hold of you if for some reason something goes wrong. This information should all live in what's called a security policy, and if you're a frequent GitHub user, you might be familiar with this as a security.md file. This information should say how to reach the VMT, what to include in your report, and it's really important that you set response expectations. You can kind of think about this like a customer service interaction. If you send a ticket in asking for some help and you get radio silence for a week, you're going to assume that nobody's there to help you, and you're either going to give up or find a different way to get your issue out there. If you at least get, hey, thanks, we got your report, we're going to take a look at it, you know that help is on the way, even if you didn't get all the answers in that first interaction. So the issues come in, it's acknowledged, and then assessment starts. So not everything is actually a vulnerability. Vulnerabilities need to give undetected access or compromised data, and that typically falls in the categories of data integrity, availability, or confidentiality. Saying this is a bad design decision or here's a suggestion for improving security are not vulnerabilities. Those are things that can be handled in the open in public issues for your project. When we do see that something is not working as intended and gives that unintended access, then we do have a security vulnerability. And what do we want to do with it? We want to patch it and get a CVE like Oliver was talking about. So researchers have lots of different reasons for finding issues. Don't just assume that they're going to send you the issue and they have no interest in helping you or no interest in figuring out what the patch is. They might actually be very invested in finding that patch and working with you. So my advice is to always just ask. Let them make the call. If they want to help you out, be involved with that. And besides, it's open source. I don't think many of us are in a position to say no to extra hands. For that patching, you're going to want it to be done in a private environment that has restricted access. Everything needs to be logged and can be made public after disclosure. If you use something like GitHub Security Advisory, that meets those requirements. But in the guide, you can see some of the qualities you're going to look for if you're not a GitHub user. While the patching is happening, you're also going to want to kick off the process for requesting a CVE for the vulnerability. There's more information about this in the guide, but I really wanted to call out crediting the researcher. It's so important that we thank people for coming to us and finding these vulnerabilities and helping us out, and giving them credit for their report if they would like it is a very critical way to do that. So finally, let's talk about this 90-day thing. This is stemming from the coordinated part of coordinated disclosure. It's really important to have an agreed upon timeline. This means the reporter knows that you won't sit on their finding indefinitely. Reporters really like to see things disclosed and credited as quickly as possible. And if you do sit on it for some reason, they can go ahead and share that information because notice and time were given to address the issue. 90 days at a maximum is kind of that common etiquette. This 90 days starts when the reporter first emails or notifies the project, not when you get a chance to respond to them or when you get around to working on the issue. And the 90 days is really your maximum time frame. Closing issues much sooner than that is always preferred. I should also mention it's not universal. Sometimes, depending on the severity of the vulnerability or a researcher's preference, they might not want that. They might want 7, they might want 30. And so it's just important that you talk and figure out what's going to work for both parties. So now We have a documented issue, a patch, and a CVE, so let's get this thing ready to disclose. You might notice that I skipped embargo notification, which is up there as the 5th step. This is actually a really complex process, and it only applies to a small group of open source projects, typically when there's a robust vendor ecosystem around them. It's a really careful decision to do this with additional responsibilities, and so all that information is in the full guide on GitHub. When you're ready to disclose your project or your vulnerability, you're going to want to send out a security advisory. These should be very factual and brief, get straight to the point about what somebody needs to know, affected versions, how to mitigate it, save things like how I found this or this wild fact about how this vulnerability works for things like blogs and tech talks. There's also no point in hiding this information. Security through obscurity isn't really much security at all, and a user can't protect themselves from what they don't know about. So putting things on your mailing list where it's appropriate, setting up a security advisory page, those are all really good ideas. And there's nothing wrong with having a lot of CVEs for your project. It doesn't mean that your project is full of security holes. It means you have a really robust response to responding, finding solutions, disclosing, and moving forward and hardening your project. So it just helps everybody the more we can have this information public and shared. And of course, we want to give our reporter a heads up before we do the disclosure and again, thank them. It's just such an integral part of the process. And there you have it. We have taken a reported vulnerability from being a reported issue to intake, assessment, getting a CVE, patching, and then finally disclosing. So the TLDR, particularly for the project maintainers here, is to have a plan before you need a plan. Know who's going to take in issues, who's going to respond, templatize those communications as much as you can, and really get that security policy in place. That's how researchers will know how to report issues to you. And inevitably, you will get something, and don't panic. Researchers are human. It's a good sign that they contacted you. It means that they want to see this through a resolution. They want to work with you. So say that thank you, take a breath, and walk through your process. And if you're a project user, it's important that you know where you should be looking for security announcements. How do you stay up to date on this project? What do you do if you come across a potential vulnerability yourself? Be familiar with the process and where to report. And of course, in the spirit of open source, take a look at your team. Is anybody good at organization, communication? Does someone have incident management experience? And can you help out with vulnerability management for the projects that you use? So there's that guide where you can read more in depth about all these things and find the runbooks and the templates. I really love seeing open source projects have effective disclosure practices. So you can find me on Twitter for any questions, comments, and the occasional dog photo. So thank you so much.